Hello everyone, in this video I just want to talk about the details of DIC and the steps that you require to do for doing a DIC. So for doing DIC, first of all, the first question that you need to answer is that do I need to do DIC or not? So maybe you don't need DIC, maybe you can measure the displacement and measure the strain of the specimen with the strain gauge or with other kind of other methods of measurements. But if you want to do DIC, you need to convince other people that you need to do DIC. So this is the first question that you need to answer. Second one, when you need to do DIC, you should prepare your specimen. So for instance, let's say your specimen is a kind of dog bone like this, and in this dog bone, it's based on ASTM, and first of all you need to paint the dog bone with white color. So this is, for instance, your area of interest, so you need to put a spray with spray with white color. I just put it here as gray just to show you it's like a white color, and then you need to put black dot speckles like this, because you want to track these speckles with digital image correlation technique and with the camera. And you need to be very careful with these speckles. These speckles should be very clear in the digital in the optical point of view. So it should be very clear, and you can use airbrush, or you can use a spray to put these speckles. It depends on the size of your area of interest. And after that, your specimen is ready, so you can go to your lab and start your testing. So in the lab, you probably have the digital image, the camera. So this is the camera, for instance, camera number 1, camera number 2, and this is your specimen, and this is your tensile machine, for instance. So you put your camera in this way with the angle of like 15 degrees or 45 degrees. It depends on your area of interest, but it probably, and yeah, it's very appropriate to have a symmetric position with two cameras like this. And then you need to make sure that the force that you are measuring from here, the reaction force, the reaction force should be imported to the DIC computer. So this is DIC PC. So you need to import this, because at the end you measure the displacement at this computer, and you also need to have force in this computer. So you want the force and you want the displacement. And from your tensile machine also you get force and the displacement, but the displacement that you are getting from the tensile machine is basically the displacement of two fixtures, but the displacement from the DIC is of course the displacement field. So this is what you need to do. You need to make sure that the displacement and the force, particularly the force, are imported to DIC PC. And when you are making sure that when you make sure that the force is imported properly into the DIC PC, then you need to calibrate your camera. I put it in step number 4. Why? Because when you calibrate your camera, you should not touch the cameras. So what does it mean? Calibration, what does it mean? The calibration, it means that, so we have a coordinate system like this. We have a coordinate system, let's call it is the coordinate system of a specimen, and we have a coordinate system of the global coordinate system. So we have the global coordinate system and we have a coordinate system in the camera. So what we do here is that when the specimen is moving, we want to measure the displacement based on our camera, and we want to compute the relative displacement between the pixels here. So this gives us the displacement field. So we need to map the coordinate system of the camera with respect to a global coordinate system. What we need to do is that we want to find a rotation matrix and a translation matrix to map this coordinate into this coordinate. In order to find out these two matrices, we need to do a calibration. So imagine that the camera is like this. So I need to know that what is the relationship between this coordinate of the camera and this coordinate. So we need to calibrate our camera. And once we do the calibration, the coordinate system of the camera, of course, should remain the same coordinates. So do not touch the camera after calibration. Otherwise, this calibration, it's not working anymore for you. So it's a different calibration. You need to do another calibration. So for calibration, we have a card. So in any kind of digital image correlation technique, or the company that you bought your camera from, there you have a calibration card, and in this calibration card we know the pattern, a known pattern with a specific dot somewhere. So in the software that you are using, these patterns are known. So the software know exactly the distance between the dot in the pattern, and you put it in front of the camera, and then you put three translation, X, Y, and Z, and also you do 3 rotation in 3 axes. So for each translation, you need 3 translations in each direction. So it's 9 translation and 9 rotation for each direction. Then around 18 and maybe 6 random translation or rotation. So maybe we need 24 or 27 translation and rotation. And based on that and the software that you have, then we can do a calibration. And when you do your calibration, your camera is ready to use. So then you use DIC and you run your test. And the last step is to post-processing your result. And post-processing, you can compute the displacement field, and then you can compute the strain field. Thank you for watching this video. I hope you have fun in your DIC measurement.